When German intelligence officers first received photographs of British factories assembling military aircraft from plywood and balsa wood in 1941, their reaction was predictable: laughter. Berlin's propaganda machine seized upon this apparent desperation, broadcasting mocking commentary about Britain's furniture factory bombers. Luftwaffe pilots were briefed that these wooden contraptions would splinter like kindling under cannon fire. Within 2 years, those same pilots would be filing frustrated combat reports about the impossible aircraft they couldn't catch. The de Havilland Mosquito shouldn't have worked. Every principle of contemporary aircraft design argued against it. Modern bombers required heavy armor plating to protect crews from enemy fire. They needed multiple gun turrets bristling with defensive weapons. They needed robust metal construction to carry substantial bomb loads. All of this translated into weight. And weight meant flying slowly and predictably, but that was considered the unavoidable cost of survival. Geoffrey de Havilland Jr. proposed something radical in October 1938. Abandon conventional wisdom entirely. Build a bomber so light and aerodynamically efficient that it simply outran enemy fighters. Eliminate armor because shells can't hit what they can't catch. Remove gun turrets because you won't need to fight back if you're always ahead. Construct the entire airframe from wood because it's lighter than aluminum and, paradoxically, might prove more resilient. The Air Ministry officials who initially rejected this proposal can hardly be blamed for their skepticism. De Havilland was essentially suggesting they replace modern materials with techniques from the previous century. But as Britain's situation grew desperate in 1939, they authorized a prototype. What emerged would revolutionize aerial warfare. The Mosquito's construction method was ingenious. Thin sheets of Canadian birch plywood sandwiched balsa wood, all bonded with Ecuadorian resin. These composite layers were molded in enormous ovens, creating curved sections that fitted together seamlessly. The result was a monocoque shell structurally strong yet remarkably light, with a smooth exterior that minimized drag. 2 Rolls-Royce Merlin engines, the same power plants that made Spitfires legendary, gave this wooden aircraft astonishing performance. When the prototype first flew on November 25, 1940, test pilots returned with reports that seemed too good to be true. The aircraft handled like a fighter despite its bomber classification. In level flight at high altitude, it exceeded 380 miles per hour faster than most contemporary fighters. With throttles fully advanced, it could reach 400 miles per hour or beyond. This was unprecedented speed for an aircraft carrying a bomb load. German fighters of 1942, like the Messerschmitt Bf 109, could manage approximately 350 miles per hour in level flight. The Focke-Wulf FW 190 was slightly faster. Both could briefly exceed 400 miles per hour in steep dives, trading altitude for velocity. But the Mosquito maintained its speed advantage at operational altitudes above 25,000 feet, where thin air reduced engine performance in conventional fighters. The wooden bomber simply flew away from pursuits. Combat reports from 1942 and 1943 document Luftwaffe frustration. Pilots executed textbook interceptions, gaining altitude advantage, diving to build maximum speed, positioning perfectly for firing runs. They closed within range, pressed triggers, watched their cannon shells strike the wooden fuselage, and then watched in disbelief as the Mosquito accelerated away, damaged but airborne. The aircraft they'd been assured would disintegrate under fire kept flying. The wood's behavior under battle damage surprised everyone, including British designers. When explosive shells struck aluminum airframes, metal tore catastrophically. Cracks propagated instantly, entire sections peeled away, and structural failure spread rapidly. But the Mosquito's laminated wood construction absorbed impacts differently. Damage remained localized. Shells punched through the wooden skin, sometimes without detonating properly, leaving holes but not destroying the structural integrity. The aircraft could absorb punishment that would have shredded metal bombers. Not that Mosquitoes were invulnerable. Of 7,781 built, 254 fell to enemy action. Fire was the wooden aircraft's nemesis. Aviation fuel plus incendiary rounds could transform the wooden structure into an inferno within seconds. Crew survival from burning Mosquitoes was grimly low, but the loss rate of 2.1% per mission was dramatically better than the 5.2% suffered by heavy bombers like the Lancaster. Every Mosquito that returned could fly again tomorrow. Every crew that survived could fly again next week. German pilots received another unpleasant surprise when they encountered the FB. Via fighter bomber variant. These Mosquitoes carried 4 20mm Hispano cannons in the nose plus 4 machine guns. Luftwaffe pilots expecting defenseless bombers found themselves facing devastating firepower. The result was role reversal. Hunters became hunted. Mosquito fighter bombers destroyed over 600 German aircraft during the war. Night fighter versions equipped with radar shot down another 600 German bombers over Britain and occupied Europe. The Mosquito's impact extended beyond its combat record. It forced fundamental reconsideration of bomber design philosophy. Speed could provide better protection than armor. Agility could save lives more reliably than defensive guns. One fast aircraft could accomplish missions requiring 50 slow bombers. These were revolutionary concepts that influenced jet-age design decades later. By 1944, Mosquitoes were flying more sorties than any British bomber except the Lancaster. Yet their loss rates remained dramatically lower. They photographed targets, conducted precision strikes on specific buildings, bombed Berlin in daylight, and even breached prison walls to free resistance fighters. Missions impossible for conventional bombers. German military leadership took notice at the highest levels. Hitler personally demanded solutions to the Mosquito problem. Resources diverted to counter these wooden aircraft meant fewer fighters protecting German cities from the main bombing campaign. The Luftwaffe developed new high-altitude fighters specifically to catch Mosquitoes. But by then the war's momentum had shifted irreversibly. The wooden wonder's legacy endures in modern aviation. Today's military aircraft routinely use composite materials: carbon fiber, fiberglass, advanced plastics chosen for engineering properties rather than conventional expectations. The Mosquito demonstrated that the best material for any job isn't necessarily the most modern or advanced. Sometimes it's simply the one that works best. Only 3 Mosquitoes remain airworthy today. When these rare survivors appear at air shows, thousands gather to hear the distinctive roar of twin Merlin engines. Veterans from both sides of the conflict, now elderly, share memories of the aircraft that changed everything they thought they knew about aerial combat. The Mosquito story ultimately teaches a timeless lesson. Assumptions in warfare can prove fatal. The Luftwaffe assumed wood meant weakness and desperation meant inferior design. Those assumptions cost them dearly. Success belonged not to those with the most modern factories or materials, but to those who thought differently, challenged conventional wisdom, and transformed limitations into advantages. They laughed at the wooden plane. Then they couldn't catch it.